right, so we have a 35% chance of a person voting for a particular party in the coming election. Some people are chosen at random, so X is the number of people that will vote for the party, and we know that the probability that X equals 2 is about 0.3. So we want to determine how many people were surveyed. Well, I know that my probability is going to be N choose R, so in this case my R value is 2. My probability of success is 0.35, so that's happened twice. And then 0.65 is going to happen N minus 2 times. So N choose R, that's going to be N factorial over 2 factorial, N minus 2 factorial, times 0.35 squared, 0.65, N minus 2, and then I'm going to have it equal to this probability, 1, 0, blah, blah, blah. This I can simplify. This is going to be N times N minus 1 over 2. That will cancel. So I can come and put this in my calculator. So I'll turn off my plots, and then I'll have N times N minus 1 over 2 times 0.35 squared, whoops, not X, squared, and then times 0.65 raised to the X minus 2. And now I'm going to look at my table of values and see if I can find that 0.3 value. Looks like it's down here at 4. So I'm going to go into the column to actually see the values. And there's my 3105375. So N is equal to 4. So I can come in and fill in this table, 3, 4. I know this one, of course, 3105375. And then so now that I know that, and that is actually not the value for 4, that's the value when I have two people voting. So now I'm going to come in and go into my y equals, clear this out, and make this a, whoops, I want a distribution, binomial PDF. All right, let's try that again. Distribution, binomial PDF is A. So I have 4 trials. Probability of success is 0.35. My X value is going to be X. And now I can go ahead and see that. All right, 0.17851. And then all these other values, 38448. And let's see what else. That one is the one I know, 0.111. And then at 4, 0.015. So if I look at this, this is not a symmetric distribution like I had last time with getting heads in 6 coin tosses. Instead, this one appears to be skewed with more data on the left-hand side, so I say that that's a positive skew. The main fact here, though, is that it's not symmetric, so not every binomial distribution is symmetric. All right, so I can calculate my mean and standard deviation. Let's go into our list and get it calculated there. So in this case, I need to change and delete out these two. Over on this side, I'll clear it out and then put in my binomial distribution. So up into list 2, distribution, binomial, same thing, but now my X value is going to be list 1. And there's my values. So come back out, and then stat, calc. All right, so my mean is 1.4. My standard deviation, let's go ahead and find that exactly. So I can go up. Oops, let's go down, copy this one. And I get square root of 91 over 10. Or, again, we had that as root 91 over 100 if we kept it all the same way. So my values of n was 4. My p-value was 35%, so I could think of that as 35 over 100, or I can think of that as 7/20. Q then is 13/20. So 1.4, well, let's look at 7/20 of 4. I get the same thing, I get 1.4. So mean is NP. My standard deviation, 91 over 100. Well, let's see what happens when I multiply 7 times 13. I get 91. If I multiply my denominators, 20 squared is 400. But then if those were my denominators, they would cancel with the 4. So my standard deviation, square root of NPQ. So there we go. These are in our formula booklet. Let's see here. So we don't have to memorize these. We don't need to be able to prove them. Your formula booklet, though, says variance is NP1 minus P rather than saying NPQ. But same thing.